So hello everyone, today we are going to start quantum computing, and here we are going to learn first classical information, and from this part we are going to learn about now bits, and from this we are going to cover in this video three parts. One is coins, dice, and encoding information. These three topics only. First we learn our bits. Bits, you all know that bits are, everyone called it 0 and 1. So how can 0 and 1 are used in computer? The device you are using for watching this video is made using 0 and 1. So how 0 and 1 used here? Let's learn about this. Let's start with coins. So what is coin? It has two outcomes. One is head and another one is tail. So here is a coin. You can see it is head portion and it is tail portion that we consider. In cricket too, we use coin for deciding whether one team will do bat or bowling. So there, if I toss one coin, then I got head portion. So in tossing one coin, I will get either head or tail. So if I toss two coins, then I will get either head or head. First one is head, second one is also head. Then first one is head or second one is tail, or first one is tail, second one is head, or both of them are tail. I will got this probably I will got these four outcomes. So now let's toss three coins together. What will be the outcomes we will get? What are the probable outcomes that we could get? So they are head, head, head. First one is head, second one is head, and third one is also head, or head, head, tail, or head, tail, tail, or tail, head, head, or tail, tail, head. And what's remaining? Head, tail, head, or tail, head, tail, 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 tail. 1 2 3 4 5 6 and 8. So we will get this four probable outcomes. So we notice that in tossing one coin we will get either head or tail. In tossing two coins we will get this 4, and in tossing 3 coins we will get this 8. So what it stands for? When I tossing one coin, I am getting two probable outcomes. And in tossing two coins I will get 4 probable outcomes. In tossing 3 coins I will get 8 probable outcomes. So if I toss n number of coins, so I will get 2 to the power n number of outcomes, isn't it? Just see, when I toss one coin, then I got two probable outcomes. When I toss 2 coins, then I got 4 probable outcomes. When I toss 3 coins, then I got 8 probable outcomes. So this was all about coins. And can you tell me what will be the total number of outcomes if I toss 5 coins? Comment. Now let's talk about dice. Well, I do not have any dice, so what dice look like is like this. So when I toss one die, then what are the probable outcomes? These are 1 or either 1, 2 or 3 or 4 or 5 or 6. Okay, isn't it? So what will happen if I toss 2 dice at a time? Then let's find out the probable outcomes. So first one is 1 1 or 1 comma 2 or 1 comma 3, 1 comma 4, 1 comma 5, 1 comma 6. Notice that this is of the first die, this is of the second die, this is of the first die, this is of the second die, this is of the first die, this is of the second die. Okay. So if all in those 6 times, if first one die have 1 as a outcome, then also we have 6 different outcome of 2 dice. Now let's do the other ones. So now see, when I toss 2 dice at a time, then there are total 36 probable outcome. So see, this is a huge. So can you tell me how much, what probable outcome will come if I toss 3 dice at a time? And it's 2 1 6. How I do that? So let's see. Just like coins, we have done 2 to the power n for finding total number of probable outcomes. For dice, we will do formula 6 to the power n. So for 1 dice, 6 to the power 1 is equals to 6. For 2 dice, 6 to the power 2 is 36. For 3 dice, 6 to the power 3 is 216. Here n is the number of dice, or here n is the number of coins. So this was all about dice and coins. Okay guys, what you learn about coins and dice are very much easy, and encoding information is also easy, but it's bit tricky than coins and dice. So let's start this. So let us consider, okay, okay, colors of the rainbow. So what are the colors of the rainbow? They are Vibgyor, VIBGYOR. You all know this. V for violet, I for indigo, blue, B for blue, G for green, Y for yellow, O for orange, R for red. So I want to represent these colors with those of code that I obtain from dice and coins. So let's do this. So let us now represent this color. So sorry, I have done a mistake in that I can't write the code of for violet, so forget that. Okay, now we will represent violet with 3 coins. Okay, let us with H, indigo with T, or okay, blue with T, whatever you can do with. Okay, H, or T, and what left? T, H. Okay, but you know that there are total 8 outcomes for the coins, so I am removing one because we have 7 colors for the rainbow. Okay, now let's do with dice. Whatever I can take, 1 comma 2, 2 comma 3, 6 comma 1, or 1 comma 4, 3 comma 4, or 6 comma 6, 1 comma 3. Okay, you know that for 2 dice there are total 36 outcome, and I have taken only 7 of this. So what you will do, if someone asks you coins code for violet, you will give H H H. For code for dice you will give 1 comma 2. For blue you will give H T T. For dice you will give 6 comma 1. So notice just one thing. See, for violet you have to use 3 coins, and for dice you have to use just 2 dice. So within these 2 dice you can tell this information, and but you have to take 3 coins to represent this information. Now recall, how many states does one coin have? One coin can have 2 states. One is head, or and this another one is tail. Okay, how many states does dice have? 1 2 3 4 5 6. Okay, so now let's look at this. You have, for 3 coins you have total probable outcome is 8. Means that with this vibrato you can represent one more color with these 3 coins. And see the case for dice. You have total 36 probable outcomes. You can represent 36 colors with this only 2 dice, but with these 3 coins you can represent only 8 colors. You can represent only 8 informations, and with these 2 dice you can represent only 36 colors, 36 information. So for storing more information you will use these 2 dice. You will not use these 3 coins. Okay, right? So the fewest number of states possible is 2. And coin carries this only. So just remember one thing from this encoding information. Remain the smallest information can be stored in these 2 states. Two states can be used to store smallest amount of information. I am writing this. 2 states is used to store smallest amount of information. So this was all about encoding informations. Thank you guys for watching this.